Dev in 1786, an Italian scientist was researching and dissecting a frog. But his scalpel accidentally touched the frog's nerve, and suddenly, the frog's leg moved. Curious, Galvani placed the leg outside to see what would happen. He noticed that the frog's leg twitched whenever lightning struck, a true mystery. But what was actually going on? At that time, people had just begun to understand that lightning was electricity, and electricity could make things move. Galvani started to think the twitching of the frog's dead leg was connected to electricity. So, he repeated his experiment. He separated the dead frog's leg from its body, placed it on a hanger, and connected its nerves and muscles with brass. The result, the frog's leg twitched on its own. Then concluded that animal bodies contained electricity, and the frog's leg movement came from animal electricity. Galvani's conclusion caused a stir worldwide. But not everyone agreed. One of them was Volta, a name you've probably seen in textbooks. When Volta heard about Galvani's experiment, he suspected the electricity didn't come from the frog itself but from the interaction of the two metals used to connect the nerve and muscle with the metal plate. That, he argued, was what triggered the frog's reaction. To investigate further, Volta built a device to prove it. He stacked two different metals with thin cloth soaked in salt water, then connected both ends with a wire. Since there were no tools yet to measure electricity, he tested it in a shocking way. By touching the wire to his hand, tongue, and even his own eye. That's some serious dedication. But why could stacks of metals and wet cloth generate electricity? Electricity is created when electrons, tiny particles, move. Metals also contain electrons, but each metal behaves differently. Some prefer to release electrons, while others prefer to attract them. Volta used two such metals in his device, and the saltwater-soaked cloth acted as a bridge, letting electrons move to balance out between the two metals. Volta's discovery became the foundation of the world's first battery, paving the way for advanced theories of electricity and eventually the electronic devices we use every day. Still, in the future, scientists discovered Galvani wasn't entirely wrong. Living organisms do contain electricity. Science always evolves. Sometimes a theory takes hundreds of years to be fully proven. Today, we access electricity through cables, much like how the internet works. Our digital world exists thanks to thousands of kilometers of internet cables. The problem is, some people recklessly cut these cables, not realizing that breaking an internet connection can cripple online trade, disrupt banking systems, and cause losses worth billions. So yes, if you ever see internet cables, don't tamper with them. Because of the internet, you're able to watch this video right now. That's why internet cables must be protected and maintained, not damaged. Let's not lose our connection just because of careless hands. And as always, thank you.